Chapter 8, Objects and Classes, Part 1. So our goals for this chapter are to understand the concepts of classes, objects, and encapsulation, to implement instance variables, methods, and constructors, to be able to design, implement, and test our own classes, and to understand the behavior of object references, static variables, and static methods. Object-oriented programming is a different type of programming than we've been working with so far. So far we've learned structured programming, which breaks tasks into subtasks, and we write methods that can be reused to handle tasks. In objects and classes, we can build more larger and more complex programs, and we can model objects that we use in the real world. A class describes an object with the same behavior. For example, a car class describes all passenger vehicles that have a certain capacity and type. Java programs are made of objects that interact with one another, and each object is based on a class. So you may recall or have observed so far that all code in a Java program goes in a class. We'll see an exception in the next chapter, but heretofore, all of our code and most of our 99.9% of our code in the future will all go in a class in Java. A class describes a set of objects with the same behavior. So each class can have attributes and behavior. So settings or characteristics and actions, behavior, methods that act on that data. So each class has a specific set of methods to use with its objects. For example, if you think about the string class, it has a length method and a char at method. The length method will return how long the string is, and the char at method will return a character at a specific location in the string. So in a class, the data is typically kept private. So when you create data in a class, you make sure that it's private. The private data is only accessible within the class. It's accessible by methods which act on that data. That's called encapsulation. Grouping data and methods that act on that data into one unit is called encapsulation. The public interface of the class is the set of methods that allow a client of the class to interact with that class. Basically, the public interface is all the public methods in the class. So let's take a look. Is the method call helloworld.println legal? Why or why not? It's not legal because hello world belongs to the string class, and the string class has no println method. We would use system.out.println instead. When you use a string object, you do not know how it stores its characters. How can you access them? You can access them by using the char at method in the string class. Also, through the substring method that will return a substring or part of a string in a given string. Describe a way, sorry about that animation. Describe a way in which a string object might store its characters as an array list as a char array. We saw in the previous chapter, in chapter 6, array list was a way of storing data, and if we store a character as each element in the array list, that might be a string. Also, as an array of char, that might be another way to store a string. Suppose the providers of your Java compiler decide to change the way a string object stores its characters, and they update the string method implementations accordingly. Which parts of your code do you need to change when you get the new compiler? None, because the methods will have the same effect, and your code could not have manipulated string objects in any other way. So think about it. If you're changing the contents of the methods, that doesn't necessarily mean that you have to change the method header or the way the method is called. So let's think about a simple class. Let's assume that we want to implement a tally counter. Note in the picture, it models a counter where one just clicks a button and it increases the counter. This can be used frequently to keep track of people entering a room, say, or people going through a turnstile. If we create a tally counter class, it can model the mechanical device that is used to count people. For example, to find out how many people attend a concert or board a bus. And what would it do? It would increment the tally and it would get the current total. Because you think about it, with a mechanical tally, that's all it does. You increment the counter and you get the total. So here's what this might look like. we would need to know what data we need. That's called our instance variables. And the only thing that we need is the number on the face of the tally. So we're going to call that value. Each object instantiated from the class has its own set of instance variables. So each tally counter has its own current count. In the graphic there, it shows that the variable is called value. So it can either be called value or it can be called count, but note that those refer to the same basic idea. Our access specifiers for our classes are going to be public, and for our instance variables, we're going to make them private. Throughout this class, we only need to be concerned with the access modifiers public and private.